Often in the exam, you will get a question that involves both sine rule and cosine rule, and this is one of those. So in this question, we have two bisecting lines, and these create two triangles. We're given the various dimensions here, and we're asked to work out length DE. So if we look at the question here, DE is the distance on the right hand side here. And here's a clue on how to answer the question. If we are expected to find something in this triangle here, the chances are you're going to start on this triangle here. Now, looking at the diagram, we can straight away notice that this angle and this angle would be the same because we have bisecting lines. When we have bisecting lines, the opposite angle will be equal. And looking at the triangle on the right, if I can find this angle here, I will know two sides. So the angle between two sides, we can find the opposite side, and that is the cosine rule. So we'll be using cosine rule in the second part if we can find this angle. This angle comes from this triangle. And on this triangle here, we have a matching pair of angle and side. But the angle we're looking for isn't matching the side here. We have a side here. But we can use this matching pair here with this pair here to find the angle at B. If we know the angle at B, we have two angles, then we can find the missing angle here with the angles of a triangle. So opposite side and angle here is sine rule. So we will do sine rule, followed by area of a triangle, opposite angles equal, and then cosine rule. That's the plan. So let's get started with this. We're going to have the sine rule, first of all, which you're given in the exam. Something like this: a over sine A equals b over sine B, and that equals c over sine C. We're not going to use all three parts, we never do. But that's the layout really for the sine rule. So we are looking at this matching pair here and this pair here. So we're going to do 31 over sine 64, that's the first matching pair that we know, equals 24 over sine, in this case it is actually angle B. So what we've written here is one equation where there is one unknown, B, and we can rearrange this and solve this. So if we multiply both sides by sine B, we get 31 sine B. If at the same time we multiply both sides by sine 64, we get 24 sine 64. We want to isolate sine B, so we're going to divide both sides by 31, so 24 sine 64 over 31. And then B is simply going to be sine to the minus 1 of that expression there, 24 sine 64 over 31. Put that into a calculator, we get the angle of B is 44.09. So if angle B is 44.09 degrees, that's this angle here, 44.09. We can now work out the angle here, angle at C, because it's just the angles in a triangle making 180. So we would say something like that the angle BCA, and I'm not going to call it angle C because it can kind of confuse things with the image. Angle BCA is equal to 180 subtract 44.09, should put that in brackets, plus my 64. Take away those two angles, and then I'm going to end up with 71.90, and there's a few other things after that, degrees. So that is my angle here, 71.9, which is also my angle here. And now I'm going to use that to work out my length of DE. So I know the angle DCE is 71.9 degrees from the first part of the question. And now I have an angle in between two sides that I know, trying to find the third side, the opposite side. That is the cosine rule, which again is given to you in the exam paper. So that is a squared equals b squared plus c squared minus 2bc cos a. And what have we got? Well, a squared is going to be it's the side opposite the angle. This here, A, relates to this angle here. So it's this side opposite this angle. So what I have here is DE squared is equal to 16 squared plus 19 squared minus 2 times 16 times 19 times the cosine of 71.9, and hopefully you've left that number in your calculator. As a point of note, it matters not which side you call B and which side you call C. I could have put 19 squared and then 16 squared. It wouldn't make any difference because you can see the expression, it would come out to be the same. So here I just have an expression. I can put all of that into my calculator. Be careful when you do that. You might want to do it in steps. And what you then get is DE squared is going to be equal to approximately 428.166. It carries on a little bit. And then DE will be the square root of that, 428.166. And then DE will equal 20.69. Question says to 3 significant figures. So our final answer is DE equals 20.7 because there's my first 3 significant figures and the 9 tells me the 7 rounds up. So 20.7 centimeters.